equations with the coefficients linear in the two variables. So how do you know that the given differential equation will be solved using this method? The differential equation a1x plus b1y plus c1 dx plus a2x plus b2y plus c2 dy equals 0, where a1, b1, c1, a2, b2, and c2 are constants. And C1 and C2 should not be both 0. Take note of that. You have here plus C1 and plus C2. If these are both 0, then what will happen? It will result to a homogeneous differential equation. So for us to have this coefficient linear in two variables, there should be C1 or C2 only or both, but it cannot be both 0. Okay? So with this coefficient linear in two variables, you will be having here equation of lines. The two equations of the line are a1x plus b1y plus c1, which is this first one, and a2x plus b2y plus c2 is equal to 0. That is the second line. For lines, we have parallel lines and intersecting lines. And how do we know that two lines are parallel if we have these two equations? So if you take the ratio of A1 over A2, and if it is equal to B1 over B2, then the two lines are said to be parallel. But if the ratio A1 over A2 is not equal to B1 over B2, then the lines are said to be intersecting lines. Okay? So again, the solution for parallel lines is the solution of method by obvious substitution. I will be focusing more on the intersecting lines because the solution here is quite longer as compared to that of the obvious substitution that is used for parallel lines. So if we have intersecting lines, what you need to do is to find first the point of intersection. And this point of intersection will be designated as H and K. Then you will be having the introduction of the new variables that X would be equal to U plus H and your Y is equal to V plus K, wherein H and K are the points of intersection. And therefore, your dx is equal to du and your dy is equal to dv. Then after having this, try to substitute it to the given differential equation, try to simplify, and then determine what will be the resulting equation. It can be homogeneous, it can be linear, it can be exact, or anything, depending on the given differential equation. Okay? So let me give you the first example for coefficient linear in two variables for intersecting lines in particular. Y minus 2 dx minus x minus y minus 1 dy is equal to 0. So what are the two equations of the lines here? That is y minus 2 is equal to 0, and you have x minus y minus 1 is equal to 0. So obviously, they are not parallel lines. Okay? So you have no coefficient for x, and you have 1 over negative 1. Obviously, it should not be equal. And therefore, these are intersecting lines. So we find the point of intersection. So from the first equation, y is equal to 2. And substituting it to the second equation, if y is 2, then x is equal to 3. Therefore, the points of intersection or point of intersection is 3, 2. And again, this is designated as H and K. Then we let X to be U plus H, so that is U plus 3. And dx therefore is du. And your y is equal to v plus k, so v plus 2. And therefore your dy is your dv. Then after that, let us try to substitute this to our given differential equation. So y is v plus 2 minus 2. Our dx is du minus our x is u plus 3. Our y is v plus 2, so minus v minus 2. Then minus 1, and our dy is dv is equal to 0. Positive 2, negative 2 is 0. 3 minus 2 minus 1 is 0. So remaining now, you have v du minus the quantity u minus v dv is equal to 0. Okay? And now what is this equation? This is a homogeneous differential equation. First term, you have v, degree 1. Second term, u, degree 1. And then v, degree 1. So this is a homogeneous differential equation. And how do we solve homogeneous? If you still recall, in our discussion, we introduced v, let x equals vy or y equals vx. But since we have here v already, then let us use a new variable. Let me use the same as that in your module in which the authors made use of r. So we let v to be equal to r times u. And therefore, our dv is equal to r du plus u dr. So we substitute. So our v is ru. So ru du minus u minus ru times dv is r du plus u dr is equal to 0. Okay? And then we simplify the differential equation. You have here ru du minus u times r du is ru du. Then u times u dr is u squared times the negative, so minus u squared dr. Then plus r squared u du. Then the next is plus r u squared dr equals 0. Simplifying ru du minus ru du. And then we combine yung my dr. Unahin muna natin yung r squared u du. And then common here is u squared. Okay, so we can factor out minus u squared times 1 plus r, correct, dr. 1 minus r, sorry. Is equal to 0. And now how are we going to solve this differential equation? If we separate r from u, we divide it by r squared and u squared. So what is now the resulting equation? So you have du over u minus 1 minus r over r squared dr is equal to 0. So this is, we can take 1 over r squared and negative r over r squared. So you have here du over u minus r to the negative 2 dr plus dr over r is equal to 0. And then we integrate all terms of the differential equation. So this is ln of u, r to the negative 2 is r to the negative 1 over negative 1 times the negative, so plus 1 over r plus ln of r is equal to c, or ln of c, to simplify our results. Okay? Then, we can take this as, or we can now substitute our r. What is r? From here, r is v over u. But r is equal to v over u. Then we substitute ln of u plus 1 over r, so 1 over v over u, so that is u over v. Plus, our ln of r is ln of v over u is equal to ln of c. Applying property of ln, this is u over v plus, this is now the ln of the difference, ln of v minus ln of u is equal to ln of c. So ln of u minus ln of u. And you now have u over v plus ln of v is equal to ln of c. Okay? Or you can have u over v is equal to ln of c minus ln of v. But what is u and what is v? So do not forget to bring back the original variables x and y. So from this, we let x equals u plus 3. Therefore, u is x minus 3. And your v is equal to y minus 2. So you now have x minus 3 is equal to y minus 2 times ln of c over v. Okay? Is the solution correct? Okay, so that is now our solution. X minus 3 is equal to y minus 2 times ln of c over v. Ah, wait. Yung v pala. Sorry. I forgot to replace v. So that is x minus 3 is equal to the quantity y minus 2. Ln of c over v is y minus 2. Okay? So take note that after finding the point of intersection, after simplifying the equation, we ended up, or the equation resulted to a homogeneous DE. So at this point, we cannot determine from the given DE what is the resulting equation. It can be of any form. So you should know at this point how to identify the form of DE and then provide the necessary or appropriate solution for that. Can you identify another form of DE for this differential equation? yung ating V du minus the quantity U minus V dV equals 0. Other than it is homogeneous, what is the other form of dE? Is this differential equation? Isn't it linear? So meron tayong V dV, so obviously it is not linear in V. So let us try if it is linear in U. So if we divide it by V dV, so you have derivative of U with respect to V minus 1 over V times U is equal to, so positive V over V is 1. Lipat natin sa kabila is negative 1. So it is linear. This is linear in the variable U. So what is IF? E to the integral of negative dV over V, or E to the negative ln of V, or this is tama ba? Or that is V to the negative 1 or 1 over V. Okay? Then, after finding IF, we multiply it with SLF, and the left side should be the derivative of the product of 1 over V times U is equal to the right side, negative 1 times 1 over V is negative 1 over V dV. If we integrate, you have U over V is equal to negative ln of V plus ln of C. U over V is ln of C minus ln of V. And you have a shorter solution. What I want to show with this example actually is for you to be able to recognize also the form of the differential equation resulting after this substitution. Maybe you were not able to identify that it is linear, and therefore the first thing that you have identified is that it is homogeneous, because very obvious that they have all terms of degree 1. So you will be providing this long solution. But if once you have recognized that it is linear DE, then you will just be having this short solution. And in the end, you will also be having the same results or solution to that differential equation. It's okay if you have recognized it as linear or if it is homogeneous, provided that that is the correct form. Okay, you may use any solution. You may use linear, you may use homogeneous, or if there would be other forms that can be classified to that differential equation, then you may use any. Then we go to the another example. This is again for intersecting lines. So what are the equation of the lines involved in this differential equation? That is 2x minus y is equal to 0. And the other one is 4x plus y minus 6 is equal to 0. Okay? So finding first the point of intersections. If you add the two, you have 6x is equal to 6. Therefore, x is equal to 1. If x is equal to 1, then what is y? So from the first equation, then y is equal to 2. Therefore, the point of intersection is 1, 2, and then again, these are designated as HK. So what is the next step? We let x to be u plus h. So u plus 1 and y is equal to v plus 2. Then this is dx is du and dy is dv. Then we substitute or we replace the given differential equation. So we now have our x is u plus 1, so 2u plus 2. Our y is v minus 2. Our dx is du plus 4u plus 4 plus y plus v plus 2 minus 6. dy is dv equals 0. So you have 2 minus 2, then 4 plus 2 minus 6. That is the main purpose why we introduced this. For us to eliminate or to remove the values of the original C1 and C2 in the equation so that it will become a homogeneous or separable equation or linear. Okay? So the resulting equation now is 2u minus v du plus 4u plus v dv equals 0. Now what is this equation? Again, obviously, it is homogeneous of degree 1, u, v, u, and v. So let us introduce again the variable r. So let v equals, let me use the uppercase r. Let v equals ur. Therefore, our dv is u dr plus r du. Okay? So we now substitute it here. So that is 2u minus ur du plus quantity 4u plus ur times dv u dr plus r du equals 0. Then now we simplify, we multiply the terms of the differential equation and let us see, diba dapat pag homogeneous, we arrive at an equation that should be a variable separable equation. So let us simplify. All here with du, so you have 2u minus ur du plus. We multiply this first before we put together those with du. So 4u squared dr plus 4ur du plus u squared r dr plus u r squared du is equal to 0. So putting together those with du, so you have 2u minus ur. And here with du are these terms and this term. So you have plus 4ur plus ur squared du. And with dr plus common here and here, u squared plus u squared times 4 plus r dr equals 0. Simplifying, we now have 2u and this is negative ur and positive 4ur. So plus 3ur plus ur squared du plus u squared times 4 plus r dr equals 0. Common to the terms with du is u. So u times u plus 2 plus 3r plus r squared. Du plus u squared times 4 plus r dr equals 0. And now can we separate r from u? Yes, by dividing it by 2 plus 3r plus r squared and u squared. So resulting now, du over u on the first term. On the second term, you have 4 plus r divided by 2 plus 3r plus r squared dr is equal to 0. And now you can integrate all terms of the differential equation. First term is just ln of u. What about this term? How can we integrate that? So, what method are you going to use? 4 plus r over, this is partial fraction. What are the factors of r squared plus 3r plus 2? R plus 2 and r plus 1. This is equal to a over r plus 2 plus b over r plus 1. So we need now to determine the values of a and b. So by multiplying both sides by r plus 2 and r plus 1, we have 4 plus r is equal to a times r plus 1 plus b times r plus 2. So equating coefficient of like powers on the left and the right side of the equation, those with the coefficients of r to the 1 or r on the left is 1 is equal to a plus b. And then with the constant r to the 0, you have 4 is equal to a plus 2b. Subtracting the 2, negative 3 is equal to, so this is 0, negative b. Therefore, b is equal to 3. If b is 3, then what is a? So from the first equation, 1 is equal to a plus b. Therefore, a is equal to negative 2. 3, then you have here, 3, then minus 2 should be 1. So a is negative 2. Therefore, this is simply the integral of du over u plus minus yung 3. So minus our a is negative 2. So negative 2 dr over r plus 2 plus 3, the integral of dr over r plus 1 is equal to the integral of 0. So integrating now, you have ln of u minus 2 ln of r plus 2 plus 3 ln of r plus 1 is equal to ln of c. Okay? Then, if you want, you can simplify first, applying the property of ln so that we can remove the ln. So this is simply what? ln of, so 3 ln of r plus 1 is r plus 1 cube. And this is u, so times u. And this is r plus 2 squared, negative, so quotient. R plus 2 squared is equal to ln of c. Then we take base e of both sides. And we now have r plus 1 cube times u over r plus 2 squared is equal to c. Then, ibalik natin yung variable natin sa u and v. Ano si r? This is R. So R is V over U. Gamit tayo ng iba ulit color para hindi tayo malito. Let me use blue color. Now, so here, again, R is equal to V over U. V over U plus 1 cube over times U pa pala. Tama ba? Okay, times U. And then this is V over U plus 2 square is equal to C. So simplifying, you have V plus U over V cube over V plus 2, sorry, this is over U. Over U. 2U over U square. You have here times U. Okay, so simplify natin. You have here U over U cube is 1 over U squared. Over 1 over U squared, so wala na yung nasa denominator. So now we have V plus U cube over V plus 2U square is equal to C. Then, replace natin yung U at V. Ano ang U? X minus 1 at yung V ay Y minus 2. So, ang V natin, Y minus 2. At ang U natin ay X minus 1. So, plus X minus 1 cube over again, ang V natin ay Y minus 2 plus ang U natin ay X minus 1. So, that is 2X minus 2 square is equal to C. So, simplifying, you have X plus Y minus 3 quantity cube is equal to C times 2X plus Y minus 4 quantity square. And that is now the solution of the differential equation.